Hi guys, in this video we are going to be looking at writing ionic compound formulas. We're considering cations and anions and making their charges even out to be neutral overall. So let's give it a shot. I will do several examples to give you an idea. So our first one is copper with a +1 charge. The 1 is assumed if it's not written, and sulfur with a 2 minus. By the way, -2 or 2 minus, same thing, whatever convention you need. So copper has a +1 charge, sulfur has a -2 charge, so that's not neutral. And basically all you're trying to do is get the charges to be equal to each other, right? So you have the same positive, same negative. So if I have a +1 and a -2, then what I need is 2 of the +1s, okay? 2 goes as a subscript showing 2 coppers and 1 sulfur, right? Because this is 2 times +1 plus -2 or -2, and that will equal 0. So we're always trying to get to 0. Another thing you might have noticed, we call this drop and swap. Since this one, let me just change the color real quick. This was a 1, and this is a 2. The 1 drops down to the sulfur. We don't have to write it in the final formula because 1s are always assumed. And this 2 went over to the copper. So you can drop it down and swap it is another way that that will work. So let's try another just for good measure. This time it's going to be iron 3 and oxygen. So to get that to even out, this isn't as nice and pretty as the copper, but again, if I drop and swap, I will find that I will have 2 of the irons and 3 of the oxygens. This is rust, by the way, just, why not? Because the 3+ dropped to the O and the 2 dropped to the iron. And then if we think about it, now we have 2 molecules of, or 2 atoms of iron times +3, and then -3 molecules or atoms of oxygen times 2, and that gives you 0, right? 6 minus 6. Okay, yet another. This one is going to throw a little wrench into the works. We have Hg2, 2 plus, and CO3, 2 minus. So these are both molecules. They actually have more than one thing combined. This is called mercury 1 when there's 2 mercuries and it makes 2 plus. This is something called a polyatomic ion. It's called carbonate. But all you really need to know is that this is acting as a whole unit and this is acting as a whole unit. And the charge is counting for the whole unit. So because we have +2 and -2, we just have to stick them together. So we get Hg2CO3, and that will be neutral. Let's see, what else can we do? All right, here we've got an ion and another polyatomic thing. So this one, polyatomic ion. So we have calcium, which is a 2 plus, and they want to mix it with arsenate. I don't really see that one every day. Okay, so again, it's a unit. So the overall arsenate, don't worry about the 4 oxygens, is a -3. So again, it's kind of like the iron oxide we did. We already have a 2 and a 3, so we're going to be working with the number 6 total for neutrality, but really just drop the 3 to the calcium and the arsenic gets the 2. So 3 calciums overall, 3 times a +2 is 6, and 2 arsenates overall, 2 times a -3 is -6. Now be careful here, notice the parentheses. Okay, because you have to show that this 2 is referring to the fact that there are 2 arsenate units. And one final one just to show you kind of all the possibilities we have. This one is going to take ammonium ion Nh4 plus, so it's polyatomic, poly meaning many, atomic atoms, and another carbonate. We've got a +1 and a -2. So we need 2 of the +1. And again, I need to use parentheses to show 2 units of ammonium ion. And that can just, that'll now be a +2. So that can just attach to our carbonate, which is its own -2. So one other thing to note when you drop and swap, you're dropping and swapping the number only, not the charge. The pluses and minuses go away once you're over here with the compound. So that is all you need to know for drop and swap writing ionic compounds between a cation and an anion. And just sorry for one good more measure, just to point out, cation always goes first. So positive and then negative. All right, see you in the next one. Bye.